the last lesson of our rational expressions, and we're going to be looking at solving equations that involve these rational expressions. So there are multiple ways to do this. It's important to know that you might have a different math teacher that teaches a different way. We think, since this is your first year with rational expressions, this is the most consistent way to show you. Now, if you had a rational equation that just had one fraction on each side, something like this maybe, you could just cross multiply there, okay? The rational equations we're going to have in this lesson, though, are going to have multiple rational expressions on each side where we have to add or subtract or do something like that. So in this case, we're going to simplify the sides of the equation with multiple fractions. And basically, we're going to get an LCD on all of our fractions that's going to be the same. Now, one thing that can come up, we learned restrictions at the beginning of this unit. Restrictions are important because if we get answers that are restrictions, we have to cross them out. So looking at my full rational equation, my only restriction is that x cannot equal 2. So if I get 2 as an answer at the end, I'm going to have to cross it out because we can't divide by 0. So now moving on to the LCD. My denominators are 3 and x minus 2, so my LCD is 3x minus 6. So I'm going to multiply each fraction by what's missing, just like we did in that adding lesson. Pretty much here it's going to feel kind of like just that adding lesson, adding and subtracting lesson. This one's missing a 3. This middle fraction is missing x minus 2, and my last fraction is missing a 3. So I'm going to multiply these out. And if I'm going to go pretty quickly with this, so if you need to go back to that adding lesson and watch some of those videos, if you forget the rules for LCDs, you might want to do that. So this is 3x plus 6 over 3x minus 6 minus 4x minus 8 over 3x minus 6, and my last fraction is 15 over 3x minus 6. Now, I know it seems like an extra step, but it's a way to make sure you don't make mistakes. I'm going to combine these two fractions before getting rid of that common denominator. So I need to distribute a negative in this problem, make it addition, subtraction, and addition. So 3x minus 4x is negative x. 6 plus 8 is 14. All over 3x minus 6, and then 15 over 3x minus 6. Once I get to this point where there's one fraction on each side with the common denominator I made, basically we can just use the multiplication property of equality, which says I can multiply both sides of the equation by the same thing. So this is over 1. We know when we multiply, we can cancel anything from the numerator to denominator. So what this does in effect is it cancels out the denominator on each side, leaving me with an equation that does not have rational expressions anymore. So I'm just going to write down what's left. I get negative x equals 1. So if I divide by negative 1, that gives me x equals negative 1. The only answer that I would have had to cross out was that 2, so we can keep negative 1 as our answer. 1. The only answer that I would have had to cross out was that 2, so we can keep negative 1. So we're moving to the bottom of the page now, and we're going to look at exercise 1. Here we have actually pretty simple denominators. There are no restrictions because they're all constants, 6, 10, and 15. To find my LCD, I want to find the smallest number that all three of those go into. So a big number we could get, 6 times 15, would give me something more than I want. It would give me 90. But we actually know all of these three numbers go into 30. So that is the smallest common denominator. My first fraction is missing a 5. My second fraction needs to be multiplied by 3. And my third fraction needs to be multiplied by 2. So this is going to give me 5x minus 20 over 30 because we have to distribute here. 3x minus 6 over 30. And 62 over 30. Now we're ready to add those two fractions on the left side of the equation. 5x plus 3x is 8x. Negative 20 minus 6 is negative 26. So now we are set up to multiply by 30 on both sides to cancel out that denominator. You do not have to write over 1 with your 30s, but I'm just kind of showing why we get to cancel that with that type of structure. So now I have 8x minus 26 equals 62. I'm going to add 26 to both sides, leaving me with 8x equals 88. And then we'll divide by 8, giving us 11. No restrictions here. We can keep the 11, and that is my answer. So this one says solve the following equation for all values of x. We have 1/10 minus 1 over x equals 1 over 5x minus 2 over x squared. Since all of my denominators are monomials, the only thing that I can't use as an answer is 0, right? We know that's a restricted value if they're monomials. 10 has no restricted values, it's always 10. So next we move on to finding the LCD, which is, looks like a 10 for the numbers since these are monomials, and the highest power of x is x squared. So looking at my first fraction to get to 10x squared, I am missing x squared. My second fraction is missing a 10x. I'm going to squeeze that in here. You can also rewrite them again. Actually, you know what? I'm changing my mind to set a good example. I'm going to write this again a little more spread out. I'm going to leave a nice space so we can see what's going on. And then we're also going to use a different color. So as we said, our first fraction is missing the x squared. Our second fraction is missing 10x to get to x squared. My third fraction is missing a 2x. And my fourth fraction is missing the 10. And it's possible, just like with adding and subtracting, that certain fractions won't need anything. In this case, they all did. So we get x squared over 10x squared minus 10x over 10x squared equals 2x over 10x squared minus 20 over 10x squared. So now we're going to bring those together so that they're one fraction on each side. So I have x squared minus 10x over 10x squared equals 2x minus 20 over 10x squared. Now that we have those single fractions on each side, same denominator, we can multiply by that LCD over 1 and cancel that out using that multiplication property of equality. This is my resulting equation. I'm going to write it over here. Taking a quick look, I see that this one is a quadratic equation. It has an x squared, so that tells me I want to set everything equal to 0. So I get x squared minus 12x plus 20 equals 0. And now we need to find numbers that add up to negative 12 and multiply to 20. So that's negative 10 and negative 2. Which gives me a 10, and then gives me a positive 2. So looking back, my only restriction was 0, so I can keep both of these answers. There are two solutions to this equation.